Okay, so today we're going to download some free, which is always good, free LiDAR data from USGS. Of course, it's only going to cover the United States, and then we're going to take it to Surfer. Okay, so the first thing you need to do is search on USGS LiDAR data, or actually better, USGS point cloud data, right? And so then you should find this map, right? And so then what you do is you zoom into the area wherever you want to find out. It doesn't have everything, but it has most of the United States, and of course, you're not going to be able to find areas that are top secret. And I'm going to search on an island near where I'm from, which is Chattanooga, and I don't know where it is. Here it is, Williams Island. Okay, so I want to try to get some data from here. Now, if you look at it, essentially what you have to do first is you have to draw a polygon around the area that you're interested in. And so there we go. I'm just going to draw a square. Sometimes this is a little bit tricky. Not really sure when it sort of ends. So I've drawn that polygon. And now what I'm going to do is search products. It's supposed to tell it what sort of products. And I believe we're going to be dealing with elevation data. And let's go ahead and put everything. Well, I have LiDAR here. Let's search on DMs too. That will allow you data that could be used in other programs. So let's find those. All right, so it's given us a bunch of different files. Now, if you notice that now there's a green rectangle that's showing you the coverage that's available. All right, so let's go ahead and do this one. All right, now it's only going to cover that area. So if you wanted the whole island, you're going to have to get several different polygons. Okay, so we just go to info metadata right here. All right, can you see that? I just clicked on that, and you go down. Hopefully you can see what I'm doing here. And you will see that it's this LAZ file here, and that's what you need. Now it's going to take a minute to download, so you just click on that, and it is now downloaded. You can see it up here in the upper right-hand corner. Okay, so that's going to take a few minutes, so we will come back to that, and when we come back, we're going to go into Surfer because the data is now being downloaded. All right, we are now in Surfer, and it's been a few minutes. So what I want to do next is to take a look and make sure that I have the right file there. Sometimes mistakes are made. Now, one thing I can tell you is some of the files are so large that at least my little laptop cannot handle it. You may need, if you find the ones that are over 100 megabytes, first of all, it's going to take a long time to download, and second, it may not work that well. So let's take a look at the point cloud data. And so I'm going to open the file that I downloaded. Let's see if I can find that. Here it is. Yeah, it'll take a second to pop up because it is a pretty large file. And when you deal with it, you need to decide whether you want the whole thing. Do you want to be able to see all of the LiDAR data, or do you just want the ground surface? Okay, so, and I just want the ground surface. I just want to see what the terrain looks like. So you just click on classification and to erase everything, and then you select on ground. If you do want vegetation, you would select on those two, and you just say okay. And this is just going to take a minute to pop up here. Actually, I'm going to put it on pause while we're waiting. Okay, and so here is the point cloud data that is including only the ground surface. Now you notice that some spots are missing, and that's where houses have been removed and other constructions. Now another thing you can do is I just included the ground data, as I showed you before. If you include all the data, it's going to look a little bit differently. And so I've actually done that while I had you on pause, and that's it. That's what this is. And you'll notice there's still some missing areas, but most of the areas filled in. And so let's take a look at one thing you can do with this is you could look at the tree coverage. So for example, let's just turn it, let's look at it in 3 dimensions. And so here you can see, first of all, this is the river down here, and Williams Island is over there. But you can see all kinds of things. You can see the trees there. You can also see that there's some sort of I guess that's a tower on top of this plateau. And so this is the full data set. But again, we want the ground surface, so we don't need the trees. Now, someone else working in forestry, of course, could get rid of the ground surface and just look at the tree coverage. All right, so let's go back to this image. Okay, so that's our point cloud data. So now what we need to do though, this is really useful for us because it's raw data basically. We need to process it. All right, so I'm just going to erase this, and I'm going to go to grid, and I'm going to grid the data. I'm going to grid that same data set that we had before. So you press grid data, and this will pop up. Now, luckily, this is fairly easy. If you follow what I tell you, you can do it fairly quickly. So you just browse to find your data set. It's the same one we had before. You want to check it ahead of time because sometimes it takes a few minutes for it to process, and you don't want to sit there for too long. And so the data set's right here. It's this LAZ file. You could look at all the information, and that it is the right one. And then you just say open. And this will take a second because again, it's a big data set. It's got to look at the data before it can even start processing. Now you also have to select again for what you want it to grid, because what it's going to do is take the points, and there are going to be millions of these little points that have been recorded by the LiDAR. And so it's going to take those points and sort of tie them together into a 3-dimensional image of the ground surface. So we just want the ground surface here. All right. So we're going to clear all, and then we click ground. And if you wanted to, you could take buildings, you could take water, road surface, and so on. Now, one thing you need to realize though is that these classifications have been either made by humans or by artificial intelligence. And in either case, sometimes it makes mistakes. Okay, so then you just say okay because we want the ground surface. That's all I want here. Say okay because I want a 3-dimensional image of the landscape. It takes a while to import. As you can imagine, it's going to take a while to process, and I'll put you on pause again for that one. Okay, so now we've got our A, B, and C columns. That's going to be X, Y, Z. And so let's just skip to the end. Well, actually I can run through it, but you can basically skip to the end. I'll run through it and show you why you don't need to go through everything. Essentially, it's going to take longer, and it's going to show you all kinds of little things that, for the most part, you don't need them in everyday work, particularly when but it does show you like kind of rough map of where the points are. And then some other information. But again, by creating this data for you, it takes more time. And you generally don't mess with it. So this is the screen you would have seen if you simply skip to the end. Now, what I'm going to do is I'm going to put the spacing at 1 meter. Now, I'd like to put it at 50 centimeters, but I'm afraid that this data set's so large that it wouldn't successfully process the data. Okay, now you can look over here. We have 7,000 by 4,000. That's the size of the image, which is pretty big, right? And if I put 0.5, both of those numbers would have doubled, right? Okay, so let's just finish it off. And when we do this, it's going to take a while. So I'm going to put you on pause again. Let's finish that. And so here it's working. So here we're going to go on pause just for a second. Okay, so once it's finished processing, as long as it does successfully process. Now, if it doesn't successfully process, you need to either cut down the resolution or make the cover a smaller area, which I'd have to show you how to do that either in another video or individually. Okay, so you just go to go to home, and then you go to color relief because we want to see this landscape. You click on that, and then you find the image, which is right here. That's the one that I saved it the same name as the original LAZ file, though this is a GRD file. You can see it right there. Just say open, and it's going to open, and there you go. And so what you can see is, the colors are kind of weird because the blue is on the highest point and the green is on the lowest point. but this is Williams Island over here. Now, what I could do is I could take the select on the um, you have the map here. You don't select on the map because you want to actually manipulate the color. So you click on color relief and you look at where it says terrain, right? And you can take that and then reverse it so that the blue is at the bottom and the green, the well, whatever color that is, it's not really green. It's kind of, oh, it's that color. I don't know what the name of it is. Okay, and so you can reverse it there and just say okay. And so the blue is on the bottom. Now, what if you don't like that? Because then now the whole island is blue. That's no fun. You can go back in there and you can simply push the darker blue. Actually, what you can do is erase some of these little color coders and change this one to a darker blue. I believe it's the same as the, no, it's even darker than the first. Let's make them both this sort of dark blue here. Right, and then you push them really close together so that you're only going to get but then you need to get a lighter color. And what's going to happen? Oops, we didn't quite get it there. Let's try it one more time. Mistakes are sometimes enlightening, right? This doesn't work. I'll show you another way. Okay, so now it's starting to pop up. Now here's the way. Let's do it in a smart way as opposed to simply kind of randomly doing things. I'm going to figure out the elevation of the river, which is 637, should be meters above sea level. Although I'm pretty sure that's what it would be. I think I have this in meters. And then, you check that out and then check out the land. And Williams Island is 647 about versus 640. Okay, so then the shoreline is going to be going up from there. So 647, let's keep that in mind. So let's go back to our little scale here. And we're going to take this, the white part. Well, actually, it's already at 640. That's pretty good. But I want a little bit more edge. Push this down just a little bit. Push that over and just say, okay. And that's a little bit better. Now what we've done there is we kind of reversed it. Now you can see that the lighter colors is kind of projecting into the water. And so you're not going to have you can play around with it until you get it the way you like it. Now let's take a look at the image that we have here, not just Williams Island. You can see some farm boundaries. I didn't realize people still farmed there. You might be able to see, I don't see any Native American constructions there, but you can see on the side of this mountain, which I believe that's Raccoon Mountain. And if you zoom in, you can see there are actually rocks that have fallen down out of this erosion area right here, which is pretty cool. And again, the trees have been stripped away. And so if we want to actually see them with better detail, the resolution on this image that we're looking at is not that great. And so we can change that to 10,000 for the pixel size or the image size. And what you're going to see is that those will become clearer, right? Because the image actually has greater resolution. I believe it goes up to around 32,000. Let's put up to 30,000, see what we can see if it makes a difference at this point. I wonder if we'll even be able to see a difference here. Taking a bit of time. Yeah, we're probably gonna have to switch it back once we take a look at it because once you increase the resolution, then every time you manipulate it, it takes longer. Now that actually did that improve anything? Let's Control Z and see what happens. Control Z. Oh, it's taking time again. I can't appreciate the difference. Maybe you can, but I don't see it. Of course, if we zoomed in a bit, let's try that. This will take a minute again. Trying to pay attention to the the fuzziness. Unfortunately, it's probably going to, to switch over as soon as I blink my eye. I missed it. I was talking. Okay, now I don't see a difference. I don't see a huge difference. I'm going to control Z again. And I don't see a difference. And the reason why is that 30,000 exceeds the resolution of the original data, right? So you're not going to get an improvement there. Now, there's actually something else going on here that we need to pay attention to. In most images made by Surfer, which is the program I'm using, and other programs that process three-dimensional data, the data is exaggerated, right? So it stands out better. Now that can be good, because you can see certain features better. But on the other hand, if the real data stands out, the things that you're interested in stand out, the noise can also stand out. There is noise in this data. I mean, what am I talking about here? I mean, this is a river, right? These are not waves, right? This is actually a product of of Surfer processing the data, right? So what I'm going to do is I'm going to try to take out some of the noise, because if you do that, and all I'm going to do is actually put it to a Z scale factor of 1. In other words, there's not going to be any exaggeration, and that will tend to decrease the amount of noise and not actually bring some features out. And so you'll see that it's a little bit less exaggerated. In other words, you're not going to see bumps all over the place. So sometimes this is a good idea. Now, if you do need for example, if you were looking at these rocks, you would probably want to keep the Z factor at where it was. Let's see what they do when I change it back. They're probably going to stand out a bit. Yeah, see, they pop out a little bit better. Another thing you could do is you can change the vertical light. In other words, the position of the sun in the sky. If it's 0, it's going to be close to the horizon. If it's 90, it's going to be directly above. The horizontal light is its position actually around the edge of your image. I like to use 135 and 45, horizontal 135, 45. Now, in other software, you can actually, instead of having just one light, you can have multiple lights to allow you to put, to get rid of shadows, or, and so there are various ways you can do this. All right, so that's how you do it. You can collect data from, anywhere pretty much in the United States, or anywhere that's legal in the United States. I don't think it's a top secret place, you're probably not going to be getting data there. But that's how it's done. Here's one other thing that we can do with this data, and that's to look at it in 3 dimensions. And so actually there's not just one thing, there are multiple things we can do. But you can go to 3D view, and what this is going to do is it creates a new window, and it will allow you to rotate the image. And so it's got the trackball selected, and then you can just simply rotate it, and you can make all kinds of fun. Actually, particular for PowerPoint, you can make all kinds of fun images showing the relationship of this mountainous area. Actually, I'm more fixated on this than I am on Williams Island, because there's really not much going on down there. Sometimes it could be a pain if it's a really huge image. I mentioned this before, that if we had to raise the pixels up, it would take forever to manipulate, to move around. We just move this up a little bit. Yeah, even this is it feels like it's heavy almost. It resists movement. Okay, so that's another thing you do. What about walking around? Well, we can try it. I'm afraid it's going to take. Yeah, well, here we are. Let's see, where are we in image? Oops, this is really difficult to move. But you can walk around to some degree across the little landscape. You can also fly, but here it's moving. It's a bit slow. Looks like the vertical is a bit exaggerated. I know this because I know this terrain is not that raised. So let's lower that exaggeration down to 1. That's going to make it so it doesn't stand out as much. But this is if you want to walk around on it as if it's the real landscape. Now, of course, the figure that you wonder how big they're imagining a human is, to be able to move this fast down this hillside. You're talking about someone that's probably 30 feet tall, but Let's take a look back up the hill. Again, it's kind of dragging because the data set's pretty big. All right, so that's another thing you can do. I mean, you can actually fly across it if you can look up on how to do that. Um, you can measure things. So that's a little, that's how you get data from USGS, and you bring the free LiDAR data in and put it in Circle.